Good morning to one and all, and I welcome you for the course on Big Data Analytics. And we are in the third day of the session. And the session of today's topic is going to be Big Data Framework and Technologies. The outline of the session includes discussion on related terminologies, technologies, limitation of existing system, and big data platform processing architectures, Hadoop and Spark, followed by big data challenges. And before getting into the session, shall we have the recap on the concepts what we have discussed earlier in 2 days. So on day 1 of the session, we have discussed about what is the evolution landscape where data moved and transformed into big data. So during the roadmap or during the transformation of data to big data, there are so many technologies has been involved. That is what we have discussed, right from changes in hardware, software, storage, and moved to big data. We also discussed about who are the data generators, which made the data to evolve to a very larger voluminous heights, and we ourselves we have come to conclusion that data generators are we the human and the machines and the business transactions. And what made this thing happen? It is again the revolution technology, social media in 2010 made huge volume of data to be generated in unstructured format. And this made to move data towards big data. And we've discussed so many other things and we've discussed about the other concepts. The second day of the session, we moved into detail about the big data perspectives. So in discussing big data perspectives, we concentrated on the core of big data characteristics. So we have discussed the big data characteristics on volume, velocity, variety, veracity, value, validity, viscosity, volatility, and virality. And we are clear with the definition of what is big data is. So big data is a tool, it is a technology, and it is a platform which is used to dig deep insights from large evolution or large sources, exponential volume of data that is generated with variety of characteristics. And again, we have discussed about the big data myths. What are the myths that it is being currently available with respect to big data? So there are big data myths that it is only volume of data. It is only dealing with unstructured data. It is only data which is being generated from social media and so on. And we have also have to clarify the myths. And we have discussed so many use cases with respect to how big data has become so popular in the field right from 2010 and what is the social causes and other applications that big data is being used. So we've discussed some use cases with respect to electioneering process both in India as well as in USA. We have also discussed how big data analytics is used in water management for managing the precious resource. And finally, we have at a conclusion that data is the driving force, data is a commodity, and data is a fuel which drives the digital platform. With this insights, now we will, and again, I've left one thing, and we have also discussed in detail about the applications of big data, the uses where it can be written. The big data is used for 5 major use cases. One, it is to understand the data, exploration of data, followed by 360-degree volume of understanding the customers who take part in the business. It is used to identify risk and security, intelligence required, used for operational analysis for data generated by machines, and it is used for data warehouse augmentation. And all these things made so many other domains to take part into the new revolution of big data analytics. With this as insight, Now, data is a value component and big data is used as a technology to identify the hidden insight from the large volume of data. Moving on, whatever we have discussed is this. So the data revolution has begun. Everyone is talking about big data, and now we expect the data to talk to ourselves, say that I am here. This is what is been happening with me, what you have stored with me. And this is where I give you more validity. This is where I just increased your patterns. Now we want data to give back inputs and insights to run our business, and that is where we are going to, or big data is going to help us. And again, as a small recap, again 2.5 quintillion bytes of data is created in each day. Is, you know the answers, the machines, humans and computing systems, nothing but the business transaction processing systems. And again, a recap of the worldwide data. We know that the world has been filled with data. We are in data deluge. The world has been drowning in data since where? 2012. Why? Because of social media. So 90% of the data is being accommodated with the data that is being generated, say, after 2012. And only 10% of data is the data that is being generated from your core domain business transactions. And now, it's something new. So, what is called as big data? There is a question, because earlier we didn't have any comparison to say that this is my small data and this is my big data. Now, we are here to come to a conclusion which data is called as big data and which size of unit of measurement I call the data as big data. So there is a definition available that the minimum size that a big data file start is at least with 1 terabyte. Do you remember what is a terabyte? Yes, exactly. Container full of chips, container full of rice is called as 1 terabyte of data. That is for our easy understanding. So when the data size is more than 1 terabyte of data, it is called as big data. Why only more than 1 terabyte? Why not my GBs? Again, we have a right answer for that or a right justification for that. We'll keep that while and we look into it what it is. Before getting into why data size greater than 1 terabyte is called as big data, we'll have a detailed look on the related terminologies and technologies that has been required to have a very better understanding of the data architecture and framework. And it seems very old to see the terminologies that is being put up in the slides, such as database, DBMS, data warehouse, data mining, and something called as data lake, which may sound new to somebody and it may sound old to many of us. Now, let us look into something called as database. Yes, what is a database? Exactly, your answer is correct. Database is collection of interrelated data. We call it as a database. Then, what is the difference between a DBMS and a database? We use these terms here and there then. So now we should be very clear. So what is DBMS? DBMS is database management system, which is a software which manages the entire data that is put into the system. And this DBMS, it has variety of too many components working together to carry out the task. So DBMS, we call it as a software. Database is called as collection of interrelated data. Now again the question it is data warehouse. Yes, many of you would have come across these terms in your papers of data mining or databases or anything else. Now, what is the difference between a database and a data warehouse? It is very important to understand, because one of the use case in our big data terminologies or big data application is data warehouse augmentation and not database augmentation. It is data warehouse augmentation. So now we have to be very clear with what is a data warehouse and what is the difference between a DBMS and a data warehouse, which is very essential to understand. Now, let us say that, let us understand the importance of data warehouse with a very simple scenario. Now, somebody asks you, what is your strength? Yes, what is your strength? So how will you give an answer about your strength? We would not give our strength immediately based on the things what we have acquired within a very short period of time. So we would analyze our strength for the longer period of time and come out with all assumptions, and then we say that this is what is our strength. And this may be sometimes little bit what to say, absolute or not absolute, maybe abstract for many of you to understand. So let me give you an example. Now, when you want to construct a new house, how will you decide to go for a loan amount? So when to do a construction of a house, to go in for a loan amount in a bank, so we never ever plan based on our previous current salary. We do have the analysis part of the last drawn salary of 6 months or 1 year or 2 years. Even banks do that to understand what is it. So always we rely upon what? Your past data, which is summarized in fashion. This is what is actually. That makes a database different from a data warehouse. And again, when we look in, so you have an organization which does your retail sales. And that particular organization or that particular company, it has its branches spread all over the globe. So it has sales that has been happening on so many parts. Now, for that particular organization, to plan for its future orders and future production and future investment, they have to come to a conclusion whether they should go or not. So usually, whenever we do in any business transaction, we rely on something called as past data, not the current data which is being running in. So whenever we rely on past data, we are not bothered about the data, what is been in and out. We rely upon summarized information. What was the maximum sales during 2019, during the month of December? What was the amount of which product flourished more, or which product there was a higher demand, so that I can increase my production. So we rely on minimum, maximum count and some average measures to determine. Now we could take it from a database directly. One issue from your database is there are so much of databases spread across an organization. And whenever we want to take any decision, it requires integration of all these databases together so that we can take a summary measure. So integrating databases positioned at different location is not an easy computational task. So which is very difficult, and the database which is live in nature, which is very, very difficult to do that particular task. So slowly we have started moving to something called as data warehouse, where we worked on, or we have looked in our landscape speaking about data mining and knowledge management. So data warehouse is again a data store, but it stores data which is past information, historic data, which has been assembled in a summarized fashion. So data warehouse is very important to gain the deeper insights that has been hidden in these databases. And again, DBMS, it works on the current transaction data, and it is not based on the past data. And whenever you want to work on past data, data warehouse is the best technology that has to be adapted. I think now you're clear with what is DBMS. DBMS, to be very simple, databases is very simple. It is the current data. Data warehouse, it stores past data. with summarized data, and insights are hidden only in my past data. So this makes database different from a data warehouse. With this thin line of definition, we'll move on to the next technology, that is data mining. And what is data mining? Data mining is a computational algorithmic approach which is used to identify the hidden facts that is being hidden in the databases. Now again my question, see, I do get it from a database or a data warehouse. Why don't I get it from an SQL query or a SQL query which is available in a database? Again, in the database, we store the data. We retrieve the data using SQL. Then why should we go for data mining? Why not database? It couldn't do the job. This question should be there, right? Just coming up, lightening us, right? So the answer is we could not go along with your SQL queries. What is the reason? When we want to query a particular information, then the person who queries should put the right question to get the relevant answers. What you look in. This is where. So what information you want, from which source it has to be retrieved, what is your condition, what you want to take, and from there all those why, what, and all these components, when you put it in a right picture, you get your right accurate answers. Now, when my data size is very large, when my summary is very large, and we are searching for hidden patterns, not with the known information, only when I know, I can query to an SQL. Since I am not very clear with what I know, it is an abstract view. Somebody with my data says that your sales of a particular product A and B was extremely high during a period of December. And product B, it didn't go with the product A, along A during month of November. This is an insight which could not be queried because it is very abstract in nature. And here we rely on data mining algorithms. Data mining is an approach which is used to gather insights using computational algorithms to detect the hidden patterns automatically from the very large data sources. So this makes the database query engine different from my data mining task. And you can mine your data either from using your database or from a data warehouse, but business organization gets better accuracy only when lined with data warehouse, because it has been exclusively assembled and designed to accommodate the summarized data from various integrated data sources of the organization. Right? Shall we move on? Look into data lake. Now, since after 2010, after your social media, data started growing exponentially more and more and more, and we have come out with something called as large huge volumes of data has been piled up in all organization, creating a data lake. Now, what do the organizations to do with this data? Because in a business scenario, every data is a value component, and every time we store a data, we expect something called as return of investment from the data, ROI from the data. This is very important to do an investment in any business organization or in any business scenario. So understanding these terminologies is very, very important. So this helps us to have a very clear picture, to make us to more aware and to make us to more quite clear to get into or to understand the necessity of big data and data analytics. Now, moving on to the conventional approaches that are being available for processing this data available in databases and data warehouse. So when you look into the figure, you can find it out, data warehouse, right? And there, what do you have there? Operational systems, as your database. It collects data from so many integrated departments of marketing, sales, supply chain management, customer relationship management, and all, with external data sources connected, clarified, integrated, then put into a data warehouse. And this data warehouse are further being sub-organized into small components based on the knowledge that is required to be gathered as data marks. And now, how do you retrieve the information from these things? So two methods are there. Either is using an RDBMS based approach using your SQL queries, or using a customer framework, an exclusive framework, and fetching with this information. So we do with only these two things. But again, when we try to do with your existing SQL queries, your computational cost is very high. And the other thing it is processing such large volume of data from various integrated data sources is also, it's not so easy as we think of. So the conventional approaches use this particular methodology to fetch the data to mine the information. Now look on where data mining fits in big data. Again, I want to make this picture clear. So many of us, we have a myth. Again, data mining is something old, big data is something new. So I need not understand something about big data. No, not at all. Data mining is my core component, as an inner value or as an inner component where we follow data analytics, followed by data analysis, followed by data science. And inside my data mining, I have my data warehouse and my database management components sitting inside. Either it is connected with a tight coupled architecture or with a loose coupled architecture, right? And again, a very wonderful figure. This has been again taken in from the Google source. The differentiation between data mining and big data. Data mining gives you a very closer view of your data with lots of details, and big data gives you the entire big picture of the data patterns, giving out with lot of relationship that occurs in the data. And this is where we use your other technologies such as machine learning in for processing huge volume of data, the big data. So now I think we are very clear with the terminologies and how it is being connected with respect to the area what we are discussing. And now, okay, as of now, we have all these architectures, all these systems, and the question is, why should we move on to something called as big data? What is the limitation of the existing conventional systems, or what is your existing, what to say, we never call it as disadvantage, or normally we call it as a limitation, where this conventional traditional computing architectures do not fit into the focus of this processing this large volume of big data. Let us have a look on it. And the issues in the existing legacy system. Limited storage capacity, limited processing capacity, no scalability, single point of failure, sequential processing. RDBMS can handle only structured data, requires pre-processing of data. Information is collected according to current business needs. So there are so many things. So we'll focus upon the first 5 important things. Yes, limited storage capacity and limited processing capacity. Let us have the normal example on scalability and understand that. See, we'll be using a mobile phone with 10 GB of memory card or 16 GB of memory card. As soon as once the memory card is being filled with information, what are the other strategies we use to again store our data? There are 2 strategies. One, it is we'll remove all the information which is not relevant or which is not needed to us, right? And the other one, it is since we feel that when we need more than higher GB, more than 16, then we going for a new infrastructure. We invest in amount of getting out an other higher unit of measurement, say 32 GB or 128 or whatever it is. Now we do 2 things. One, it is removing some information, and other one, it is what is it? Going for a new investment. These are the 2 things everybody will be doing. And again, removing some information, we couldn't sit and remove one by one when we try to sit and remove or delete our messages. Do we do that? When we get that in a mobile phone, your WhatsApp has taken out this 13.13 GB of your storage space. Clear it. What do? No, we could never go on surf and find out which image has to be retained, which has to be removed, because the size of the data that has been pushed into our mobile phone from social media platforms is quite larger than the searches what we intend to do. Is it or not? Yes. So we are also facing with this storage, limited storage capacity, limited processing capacity. This is not issue of any individual as a mobile. Even when we do face, consider the business organization which store their business functionalities and business process outcomes in form of data during the era, during their digitization process. So every time when they want to do a storage or when they want to do a processing, whenever they do scale up, ends up with the higher limitation, they go in for the one thing, it is during a new investment in terms of hardware to store their details, business outcomes, because now data is a value component. Now, the business organization could not remove any of our data. If somebody removes any of our data from any of the mail, we never get into that specific mail. And when social media platforms removes all our data, what we generate, right? They couldn't do it because they have to retain our data. This we call it a CRM, customer relationship management. I'm the client, I'm the user. So my data, when it is only available, then I'll be sticking on to that specific platform. This is what all is our expectation, right? But when we look into a business perspective, these are the very two complex issues that is being faced by all business organization which generates or which are generating huge volume of data, faces with two issues. One, it is your storage capacity. Another one, it is your processing capacity. And since this ends up with my storage and processing capacity, we don't have scalability. Scalability, it is whenever something comes in new in, when my system is able to accommodate those inputs, I call my system to be scalable. Our human brain is scalable actually. Whatever we get it, we are able to recollect it, store it, and do it. It has a scaling, higher scaling architecture. But the machines, what we have, it suffers from the problem of no scalability. And one more issue with this single point of failure. Our machines, when I don't have the high-end servers where my data it is being replicated and stored at different locations, then your data failure, it occurs. And the current traditional architectures or platforms or frameworks are built on RDBMS as a technology which can handle only structured data, and unstructured data has come after 2012, which occupies 90% of the worldwide data. Now processing and storing this unstructured data, which is called as external data sources, again into your business component or your business frameworks, it's not very easy. It is again very, very difficult. So these points are the issues or the limitations of your existing legacy systems which make them difficult to get accommodate of processing the huge volume of data that is being generated, which is called as big data. And you can see the quite beautiful yellow elephant. Did you watch it on the right corner? Yes. So why an yellow elephant rather than not a blue? Because all my slides are being put up with two font colors. One is blue and red. Do we have any insight on that? Yes, we have an insight on that. Shall we look along that? And shall we look along again the technologies to resolve these issues? How do we mind value of this data? Again, why this elephant is coming back to us all the way? You have an answer? Yes, we have an answer.